Good morning, Prof. This is our project presentation for TBA2105. The title is Movie System Recommendation based on IMDb. Please allow me to have a brief introduction to our group member. Our group consists of Wang Zhiwei Darren, Lam Zichuan, Tan Li Hao Baojik, Liu Zhongshuan, and me, Li Hongyi. So Darren is doing the web scraping, and Lam Zichuan and Baojik is working with analysis, experiment, and interpretation of the results, while Zhongshuan and me is doing data exploration and data cleaning and all the rest of the stuff. So the content table. So our presentation consists of these four main categories. The introduction to business domain, data collection, data exploration and preparation, as well as experiments and analysis. Firstly, I'll talk about the business domain. So we adapt the CRISP-DM analysis process. So our analysis process mainly consists of business understanding, data understanding, data preparation, modeling, evaluation, as well as deployment. Many of the data set from IMDb. Our team mined the dataset from public databases of the IMDb. We use packages like RS to harvest data from IMDb, which could include movie names, genre, rating, and descriptions, etc. The main goal is to recommend similar movie based on our similar genre of the movie that user has selected or watched. This can be used for movie hosting streaming sites to better recommend movies to their user base. So there are countless of movies currently in circulation. For time-constrained consumers, finding the best movie according to their preferences is a potential issue. Therefore, businesses like IMDb aim to consolidate all those movie films and provide an online database for consumers to choose from. IMDb will collect all relevant data related to the movie, and we plan to harvest some of the data to better tune consumers' movie preferences. IMDb does provide movie recommendations. However, these recommendations are other movies watched by consumers who also watch the original search movie. We would like to use a different approach by recommending based on genre instead. We are considering treating each movie as a transaction and conduct a market basket analysis on those movies. This will attempt to find associations between groups of genre based on the movie. Each genre will be categorical, and we will try to identify the frequent item set. We utilize a priori principle in determining which pair of genre are popular. Finding out how genres are associated with each other. If a viewer intends to know which genre best accompany the genre of movie that the viewer wants to watch, the system can recommend the movie selected through the genre. In terms of data collection, we are planning to use the RS package to scrape for data. The data that we intend to collect will be the movie's title, rating, and list of genres. And now we go to the part of data collection. So totally, we managed to mine 1,500 plus record from the IMDb database. And this is the codes that we use for the data scraping. And this is the final result that we mine from the IMDb, and which is the database that we will be working on. So the overview of the database. So after at the end of the web scraping, we have managed to collect 1,327 records from the IMDb, with the web scraper tools. So, which means some of the bad records we have discussed. And those records containing the following fields, which have the movie title, genre, rating, as well as the number of votes. And now I'm going to talk about the data exploration as well as the preparation. So we have done a data cleaning by remove the NA records as well as the foreign characters to better facilitate our analysis. This is a process when we're trying to find all those NA values. We find quite a number of NA values, so we managed to remove all that. And we did some data visualizations to find the distribution of the votes against the rating. So after removing the few outliers which have a very great number of the votes, so this is how the data distribution looks like about the votes against rating number. We also have visualizations on the distribution of the rating counts. And from the visualization, we can roughly tell us that most of the ratings counts falls between 5 to 7. And now I'm going to talk about the experiments and the analysis. So we have do a bucket basket analysis on the title. And based on the business requirement, we split the analysis into a few areas. And for the bucket analysis, this analysis is useful for director or producers intending to title a movie. And also useful for marketers that intend to market a movie. If title transactions are shown to be frequent, provides a viewpoint for the above stakeholders to vote their movie title in order to draw the potential viewers to give it a try. So we do the analysis by supports, and we find that the highest level of the supports is only 0.4%. This indicates that most of the title are rather varied, as the title transaction do not appear frequently. This could also be observed from the counts, which the first place has only 3. And we also do it by leaf. And this is the result that come out from the analysis. Even though the highest leaf was 669, however, the count was only 1, and their support is 0.1. This indicates that even though the word bloom is extremely likely to follow after penguin, due to the low count size, the significance of this data is lessened. So in overall, about the analysis of the title, most of the title are varied in terms of their wording. The analysis provides strong significance in terms of patterns for stakeholders to potentially follow, which thus allow more leeways and freedom for their naming. We also have done a market basket analysis for general. This analysis is useful for movie streamers such as Netflix. By knowing genre are more likely to be paired together, the movie streamers could adjust their movie recommendations based on the genre that the viewers has chosen. And when we do the market basket analysis by genre by support, we see that the general drama frequently appear among the general transaction. So if the movie has a biography genre, most frequently they will have the drama genre as well. We also do it by leave for the genre of family. From the above results, the most likely genre that follow both family and horror would be fantasy. Thus, if the viewer was watching a movie that has the family and horror genre, the system could recommend a fantasy movie next. For the overview of genre, the most frequent genre among the movie would be drama. Thus, other than for recommendation purpose, companies such as Netflix could thus also identify trends in the movie genre in order to know which genre of movies are more developed. The streaming website could opt to target those more developed genres of movie in order to reach a larger target of audience. We also have a linear regression model. So based on the model of the meta over rating plus votes, the rating variable has a positive coefficient while movie has negative coefficient. This means that the higher the rating score, the higher the meta score, while the lowest number of votes, the highest the meta score. R square of 0.43 means that this model represents 43% of the data set. And the variables also have a t-value of 22.7 and negative 0.4 respectively. The rating variable provides a significant evidence against the null hypothesis, while the number of votes does not provide significant evidence against the null hypothesis. Null hypothesis referring that all coefficients in the model are equal to 0. The rating score is better predictor of the meta score than the number of votes. And this is a content-based approach of our analysis. So based on the movie's genre, we can recommend similar movie using the content-based approach. So this is the result of the analysis. So taking Eternus as the movie as an example, after running the approach, users whom like the Eternus will also most likely like the following titles, such as Dawn Part 1 and The Tomorrow Wars. And based on the movie's genre, we can recommend similar movies using the content-based approach. We previously used one movie as an example. However, we are able to run this approach with a larger number of movie base. So we're taking Eternal, Army of Thieves, and No Time to Die as an example. So after running this analysis, users who like these movies, they also like these following titles. And the content-based approach is used as there is no need for data for other users. And this approach will be able to recommend to users with unique tastes. And you're also able to recommend new and unpopular items. However, it does have a drawback. The drawbacks are feature engineering is not so straightforward, and also people might have multiple interests. And this is end of our presentation. Thank you for watching.